Let's solve this interesting math problem. We need to find the value of m such that the number of divisors of 2 cubed times 3 to the m is 20. We're looking for the value of m such that the number of positive divisors of 2 to the power 3 times 3 to the power m equals 20. First, recall the formula for the number of divisors of a number. If a number has prime factorization p to the a times q to the b, then the number of divisors is a plus 1 times b plus 1. In our case, the number is 2 cubed times 3 to the m, so the exponents are 3 for 2 and m for 3. We know this equals 20, so we can set up the equation 4 times m plus 1 equals 20. Now let's solve for m. First, divide both sides by 4. Finally, subtract 1 from both sides to get m equals 4. Let's verify our answer. If m equals 4, then the number is 2 cubed times 3 to the 4th, which is 8 times 81, or 648. The divisors of 648 are all numbers of the form 2 to the a times 3 to the b, where a is between 0 and 3, and b is between 0 and 4. Perfect. The number of divisors is indeed 20, so our answer m equals 4 is correct. Great job! We've successfully solved the problem.